I'm going to talk to you today about hydroxycarbamide. It's also called hydroxyurea. I'm going to talk about how it works and why it's important. This video is for people who have sickle cell disease or sickle cell disorder and who are thinking about taking hydroxycarbamide. So I'm going to start with what happens when you're in the womb. So everybody in the womb makes a special kind of hemoglobin called fetal hemoglobin. So here I've drawn a red blood cell, and in it are little fetal hemoglobin molecules, and I've drawn them like flowers. So they've got two petals that are orange called alpha and two petals that are pink called gamma, and together those four petals make like a little flower, and that's our hemoglobin molecule floating inside the red blood cell. Now when you're born, you stop making the fetal hemoglobin and you swap over to something called adult hemoglobin. And you can see that adult hemoglobin has the same shape like a flower. It's still got those two orange petals, but now the light pink petals have gone to dark pink. Instead of gamma globin, you make beta globin. And this adult hemoglobin also floats around in your red blood cells. And the red cells would survive around 120 days in your bloodstream. That's about 3 months. Now, unfortunately, if you've got sickle cell disorder, instead of making the adult hemoglobin, you make sickle hemoglobin, hemoglobin S. And I've drawn those as flowers again, two orange petals, but instead of the dark pink petals, you make the green petals. And those are hemoglobin S. Some people have SS, others have SC or S beta thal, but the principle is the same. These hemoglobins do not like to float around the red blood cell. And under certain circumstances, what happens is that they stack up like Lego bricks and make long chains of hemoglobin inside the red blood cell. And that's a problem because these long chains of hemoglobin stretch the cell out, and they can cause it to burst, which means that the red blood cells won't survive 3 months in the bloodstream, but rather 3 weeks or 2 weeks or even less. And secondly, these long bent blood cells will get stuck in blood vessels, and that will stop the blood from flowing normally through blood vessels. For those of you who live with sickle cell, you will know far better than me how painful that is. When you stop the blood flow to an organ, like for example, stop the blood flow to bones, it causes death of that tissue and severe pain as the body tries to send a signal to your brain that this bad thing is happening. And this is how we can explain painful crises. And unfortunately for people living with sickle cell, there's the pain aspect, but there's also the damage that's happening underneath the surface. And that's why I like to use this image of an iceberg with the pain on the top, which is what you can see of the condition, but then there's hidden damage happening underneath the surface. And this hidden damage can sometimes take years to show itself, and it can cause damage at the back of the eyes, damage to the kidneys, it can cause damage to the bones themselves, it can stop the spleen from working and make the person likely to get very severe life-threatening infections. In some people it can cause silent strokes, and in others it can destroy joints that then need to be replaced by surgery. So in order to reduce these painful crises and in order to reduce the hidden damage that's accumulating over the years, we want the red blood cells to stop changing shape, stop sickling, and we want them to stay alive for longer in the bloodstream. And one way that can be done is by waking up the fetal hemoglobin. And this fetal hemoglobin can be woken up by the drug hydroxycarbamide. Hydroxycarbamide switches back on this instruction to make the fetal hemoglobin that remains in our body but has basically been switched off after birth. Why is this important? Well, the fetal hemoglobin, it can't stop the sickle hemoglobin from making the chains altogether, but it can stop them being so long. It acts like little caps and keeps those chains of hemoglobin much shorter. And the consequence is that the red blood cell keeps its round shape for longer, survives longer, and is less likely to cause blockage, and therefore less likely to cause pain and less likely to accumulate damage. So what happens? Number one, we get increase in the lifespan of the red cell, which reduces the amount of energy required to make new red blood cells. And many people who start hydroxycarbamide find that actually increases their energy levels. And also it reduces the amount of red blood cell destruction, which is what causes the yellowness of the eyes. Secondly, by reducing the blockage in vessels, it reduces the number of red cell crises. And secondly, it reduces the number of long-term damage to organs and increases lifespan. And we know from really many years, over 30 years of experience with people who have sickle cell, who've been taking hydroxycarbamide from all over the world, in Africa, in America, in Europe, in Asia, that people with sickle cell disease who take hydroxycarbamide tend to live longer than those who don't take hydroxycarbamide, tend to have fewer complications and less long-term damage to their organs. Now, I want to make it clear that I can't promise that this is going to happen. And the way that I explain it is by comparing it to smoking. So we all agree that smoking is more likely to increase people's chance of getting lung cancer, and not smoking increases your chance of having a long life and not having lung cancer. But obviously that's not a promise. We will all know people who will have smoked all their lives and who've lived till 100, and people who've never smoked a single cigarette and yet died of lung cancer at the age of 50. It's the same kind of thing with hydroxycarbamide. I can't promise that if people take it, they will have a long life, and if they don't take it, they will have more complications. But generally, people who do take it do live longer and have fewer complications. And that's really important if you live with sickle cell disease. Now, many people quite rightly will worry about side effects of taking a medication long term, and that makes complete sense. But the safety profile of hydroxycarbamide has been studied now for decades and decades, and we're now so sure that it's safe that we have guidelines that mean that we offer it to children with sickle cell from the age of 9 months. So I'm going to leave you with one last picture. You can see on the bottom right 2 blood films, A and B. They're both of somebody with sickle cell, and you can see in blood film A there's not very many red cells, and a lot of them have got this abnormal shape, the sickle shape. However, in blood film B, it's the same person who's on hydroxycarbamide. What do you notice? Firstly, there's a lot more red cells. That means they're less anemic. And secondly, you can see that there's a lot fewer of these sickle cells. So that means you can see with your own eyes how hydroxycarbamide makes a difference to your blood. And if you can imagine that happening in your body, you can see how, over the long term, taking hydroxycarbamide means your blood cells are much healthier and you are less likely to have long-term problems from the sickle cell itself. Thank you.